So to get a better sense of what we mean by orthogonality, it helps to look at a specific example. So what I've got here are the first two wave functions for the particle in a box solution. So we have psi1 and psi2. So square root of 2 over a sine pi x over a, and square root of 2 over a sine 2 pi x over a. So if we want to show that these two are orthogonal, what we want to show is that if we take the integral from 0 to a, and that's all the space we care about for this problem, for particle in a box, we want the complex conjugate of one of these. Doesn't really matter what order we go in. So we'll put 1 first, sine pi x over a. And because this is a real function, the complex conjugate part doesn't matter. And then we take the same square root of 2 over a and have sine 2 pi x over a dx. Okay, and what we want to show is that this is equal to 0 if these are indeed orthogonal, which is what we will get. So we can take out our constants, and we'll have sine, we need 0 to a, sine pi x over a, sine 2 pi x over a dx. Now at this point, there's a few different ways we can go about solving this. We can look it up in an integral table. We could use Wolfram alpha. It's okay with me if you do that. I care more that you understand the concepts and that you remember how to do all the different rules of integration. But in alternative ways, we can come back to our idea of even and odd functions. And let's look at, in this case, we're only looking at even and odd over 0 to a instead of negative infinity to infinity. But if we plot our particle in a box wave functions, for n equals 1, this looks something like this. And so if we consider the middle of the box, a over 2, sine pi x over a, this is an even function, if we're considering it relative to the middle of the box. Now let's look at n equals 2, which is our other wave function. Looks like this. And this is the middle of our box here again. We notice that everything's positive here and negative here, and they're symmetric. I didn't draw it symmetrically, but if we actually plotted this, it's symmetric. And this, over this range from 0 to a, this is an odd function. And so if we multiply an even and an odd function, what we see is that we'll get overall, we'll get an odd function, and this integral is 0. We can also just show that mathematically too, but this comes back to this idea. So because we have even times odd equals overall odd function, and integrating over 0 to a, we get that this is equal to 0. And so indeed, this does give us the fact that these two are orthogonal. And we could show this for any possible, and you will show this on your homework, for any possible combination of wave functions, If we picked psi1 and psi5, we would still get that this integral would equal to 0. And so that's the property of orthogonality.